Cool. My friend once said that he only builds software, he's not good at using it, and I'm feeling that today. So thank you for bearing with me. All right. Hello, everyone. Welcome to my talk on driving organizational sustainability with platform engineering. So she already said a little bit about me, but before I continue, I'll just share a little bit more. So I'm currently a tech lead for the New York Times observability team, which sits under our greater platform engineering organization. So as someone who's responsible for the direction of my team and is an engineering leader across all of the Times, I spend my time thinking about the function of platform engineering and how it can facilitate success across all of the Times. And ultimately, what that looks like is coming from the perspective of enabling our department to work in a way that enables long-term organizational sustainability. And so we'll start off by talking about what I even mean when we say organizational sustainability. So more specifically, I define sustainability as the continuous practice of operating in a way that enables short-term growth opportunities while ensuring long-term success. And so there's a lot to unpack there, so let's break it down a little bit further. And so first, sustainability is a continuous practice. So even if we spend a lot of time upfront thinking about how we can ensure long-term sustainability, circumstances change, and often quickly, and we need continuous avenues to ensure long-term success. Secondly, enabling short-term growth opportunities. And so sometimes the risky short-term growth opportunities are what leads to our long-term success, right? The emergence of bundles of tools is pretty common now and has worked really well for some companies like the Times. I'm sure some of us love Wordle. And so we don't want to give that up, right? But putting on my reliability management hat, we also need to prepare for the risk of those opportunities. And so this leads us to the component of enabling long-term success. And so we frequently see companies take their core business for granted in the name of growth. But for every successful growth opportunity, right, most opportunities do fail, unfortunately. And so preparation for this type of risk is essential. And so now that we've defined the goal, organizational sustainability, let's define the strategy, which is platform engineering. And so as much as I hate repeating words on a slide, I'm going to do it if only for emphasis. So platform engineering drives organizational sustainability by practicing socio-technical principles that provide a community-driven support system for application developers using our standardized platform architecture, which is what this looks like. And so one thing that we're going to talk about throughout the talk is about how platform engineering can enable us to scale our organizations to enable growth that our businesses often demand. And as part of that, right, we need to ask ourselves, like, at what point do we actually even need platform engineering in this framework? And so we'll frequently talk about scaling software, and we frequently talk about that, but what does it actually mean to scale our organizations, right? And so the answer is ultimately that our ability to scale our organizations is directly tied to our ability to scale our software. And so when we think about scaling our software, right, we have to be intentional about addressing the inevitable complexity that comes with that growth. And so to address this complexity, we have to bring this intention into how our architecture can enable those needs. Because complexity, as we all know, right, makes development so much harder that we as a collective industry have evolved the way that we build them, right? For example, the modular monolith has become increasingly popular, especially as an intermediate step towards distributed architecture patterns. And so just like we've evolved the way that we build applications to embrace new architectural patterns like microservices, we must evolve the delivery strategies that we use to build these new architectural patterns. And so if architectural patterns are a solution to the technical complexity of scaling our organizations, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so to summarize concisely, platform engineering is a socio-technical solution to the organizational complexity of scaling our applications. And so we'll spend the rest of this talk decomposing each of these components, the principles that guide us, the community-driven support that enables application developers, and the architecture that we use along the way. And so first, we have the principles that guide us. And so having focused on reliability management, the principles we review are heavily influenced by DevOps, particularly because DevOps principles take a strong consideration for both the technical and social components of what it means to develop and operate software. And so let's head into those. And so some of us might have heard of the COMS framework, which is basically just a framework of principles that should be the core of DevOps organizations. And so while I could use all 5 here and they'd be equally applicable, we're just going to focus on 3, which is culture, automation, and measurement. So starting off with culture, the COMS framework tells us that DevOps drives a culture of continuous improvement and reduces silos by intentionally sharing knowledge and feedback. And you can note that while I removed the S for sharing, I think it shows its presence through this principle anyway. And the same here is true for platform engineering, though I'll talk about it more directly by putting in the context of community. And so in DevOps, we often talk about breaking down silos, right? And the way we bridge that is by sharing knowledge. And to share knowledge also means to connect. And so connection and communication are key for preventing silos, the silos that would hinder our ability to make continuous progress. And so when we're talking about organizations, especially as they grow, the most effective way to manifest this culture of sharing is to think about how we can cultivate a strong community that fosters this culture at scale. And because ultimately the opposite of isolation or silos is to be in community with other people. And so next, we have automation, which improves our software delivery process by reducing human error, improving our efficiency, and enabling faster delivery. And this means thinking critically about the type of work that doesn't require business-specific knowledge, and figuring out whether that knowledge can be consolidated into software that's managed centrally by platform teams. And in this, right, we get to reduce the required cognitive load that product engineers often have to indulge in by managing all aspects of their software. And the type of work that's important but can be consolidated in an automated or centralized way is work that's often repeatable and manual. Another aspect of platform engineering is how we should be explicit about improving efficiency by leaning into solutions built by third parties, whether that's vendor solutions or open source ones. And the reason for this is because we need to reduce our own cognitive load and maintenance burden just as much as we do for product engineers. And lastly, we have measurement. And so first, let's talk about the function of measurement, which is ultimately to have feedback loops for whether our work is actually having our intended impact. And these feedback loops consist of both quantitative and qualitative feedback loops for continuous improvement. And the way that this principle connects to sustainability, again, is by eliminating the time spent on work that doesn't ultimately lead to our business goals. And so, for example, right, if a tool that we spent a lot of time on doesn't actually end up serving our product engineering users, which leads to lack of adoption, all that time that we invested really could have just been directly serving our paying end users. And so we end up missing the ultimate goal of building applications that age well with our evolving product growth opportunities. And so in other words, these feedback loops just keep us on the right path towards a continuous improvement that enables us to build new features while maintaining our existing software. So now that we've defined our principles, we'll shift over to talking about the support strategies for application developers integrating with our platform. And so we'll speak to both scalable and flexible strategies and put it in the context with the ways that we measure success, consolidate efforts, and cultivate a culture that values sustainability. And so the first is the most scalable strategy of all, which is to make building sustainable software easy. And so we'll deep dive into this more in the next section when we talk about our platform architecture, but to set the stage for that, let's remember from earlier that sustainable organizations are directly tied to their ability to build sustainable software. And what we mean by that is ultimately software that ages well with evolving business needs. And so I'm sure we've all worked with software that's clearly wasn't built with much foresight in mind, right? And this is usually what we end up calling technical debt. And technical debt is, of course, inevitable, but we can mitigate its risk by being intentional and strategic about when and where we inject this tech debt. And so tech debt should ultimately have a function, usually for the purposes of growth opportunities. And tools that aren't easy to integrate are a type of technical debt that typically doesn't pay off in the long term. And so it's especially our duty as platform engineers to build easy-to-use tools to minimize the time that we need to spend supporting app developers. And now, that's not to say we shouldn't be willing to support them, right? In fact, the opposite is true. We just need to be intentional about when the right time to support is and how we can leverage a culture of communal learning and support so that we're not the singular points of failure that I meant that we're trying to avoid being. And so not only does this alleviate some tension on us, but it enables us to be more community-driven in the way that we support engineers. And so we talked about measurement as a principle earlier, and an important measurement of our effectiveness is the adoption of our developer platform. And so what intention looks like here is ultimately defining the ways that we approach support and clearly communicating it to avoid mismatched expectations that will degrade trust between platform and product engineers. And so in the interest of time, I'm only going to show one example of this, which is to provide an easy decision framework driven by the status of our tools. So we don't have time to review, but I'm going to take the opportunity to drink water. All right. And so a common pitfall for platform engineers is to take on too much integration work. And so, like the last slide showed, there's room for that, especially in the early experimental mode. But that's not scalable, and nor are we even often the right people to be integrating with our tools because we don't have application context, right? And so a relatable example here might be like testing, right? We can certainly create or recommend testing tools, but we can't really be the ones writing the unit tests, right? That requires domain knowledge, and luckily, if we're doing our jobs right, the time that we save them will free up time for them to take on this application-specific work. And lastly, driving a sustainable culture. Sustainability doesn't just apply to software, it applies to people, and the two are very closely tied. And so referencing Accelerate here, it talks about self-sustainability and the different types of burnout to look out for, whether that's physical or emotional, et cetera. Excuse me. And so our work is going to be naturally collaborative, right, and touch so many parts of our organization. And so we have a unique opportunity here to drive this culture forward with everything that we do. And lastly, we have our platform architecture, which is the architecture that platform engineers are building to support application development. And again, the function of this architecture ties directly to the first support strategy we talked about, which is to make building sustainable software easy by consolidating efforts and cognitive load centrally. And so we've talked about our high-level principles, so next we'll review a couple of architecture design principles. So the first is to embrace design-driven architecture as a core principle. And so to my final point before, we often have a more room to move with intentional design. And this intention is what enables us to minimize technical debt and risk that often leads to unsustainable organizations. And I could break this principle down a lot more, but we'll omit that for now because we're actually going to talk about design tensions and how to alleviate them soon. And so secondly, our architecture should be complementary to those of our users. Now, that doesn't mean we shouldn't try to anticipate developer needs. There's a value in thinking about where our platform architecture might be heading, but to the last principle, right, we need to design with the future in mind, not necessarily build for it immediately. And this is much in the same way that we might design a monolithic application in a way that would enable us to decompose it to a distributed architecture in the future. So when we prioritize our work, right, we should ultimately be driven by the needs of application developers in our organization, whose architecture should be a reflection of our paying end users. And so as you grow, right, themes will naturally emerge, and those will be what make a genuine difference, right? That might lead to us prioritizing certain domains, whether that's CI/CD or observability or runtime language support. And within those domains or problems that we're trying to solve, we'll also need to build it in a way that's responsive to evolving architecture and developer needs. So for example, if we want to improve the runtime experience of developers, we should prioritize the languages that are actually used by them, not the ones that we want to support first. And so ultimately, right, we're not here to tell other developers what to do, right? We're here to support them in what they need to do. And another reason this is important is because our platform architecture can easily lead to what I would call platform chaos. Yeah, I know, right? An overwhelming number of tools, especially custom ones, is not the goal, right? Tools are enablers of our goal to build successful engineering organizations. And so instead, we need to be more managers of chaos. And the way that we do that is by aligning the components of our developer platform with specific domain use cases. And this enables us to design our platform so that we can see similar benefits of concrete separations of concerns that we often see in end-user-facing architectures. And this is where I'll take a moment to talk about a common pitfall we see with platform engineering, which is that platform engineering is not equal to infrastructure platforms, right? Platform engineering is not equal to infrastructure platforms. And I think this is part of why we see the naive conversations around DevOps being dead in lieu of platform engineering. And that's because too many of us are operating under the assumption that the only shared platforms that companies need is limited to infrastructure, right? But for example, right, we could also be thinking about how platforms can aid the service or feature development cycle during the actual development phase. And that might mean having language runtime platforms that support the development of standardized Node.js services. And each of these can be decomposed even further, though again, tying to principle number 2, this decomposition should only happen if there's a genuine need for it. And so for example, right, your runtime platform might support multiple runtimes over time, and actually, in fact, they probably will because most of us have to support the browser runtime as well as the backend runtime at the minimum. And so in the infrastructure context, you might also see this further broken up by domains like cloud infrastructure, CI/CD, observability. And to complicate it even further, right, now there's an emergence of product platforms, which might refer to a specific end-user product domain or a core platform, which often you might even see as called core services, depending on organizational structure and just sometimes random naming conventions. And lastly, choosing boring technology. So this ties back to what I spoke about not building tools from scratch, or at least that not being your first instinct. And we should also not be leaning into every cutting edge opportunity, right? And so some years back, a blog post named Choose Boring Technology, which was by Dan McKinley, went kind of tech viral. And he talked about this idea of innovation tokens and how we need to be intentional about where we spend those. And so this resonated with me, right? Engineers love to play with toys, but every proof of concept shouldn't be making it to production. And I acknowledge that this is tempting, especially because orgs like CNCF are always building cool new standards and tools, but recency bias shouldn't be driving criteria, it should just be informing it. And one of the most seen as boring technologies are docs. And so a lot of internal developer platforms can honestly be replaced by good best practices and standard documentation. And that's not a wasted effort, because even if we do end up building a new tool for that, usually that ends up being a pretty good start for design and requirements gathering anyway. And so first, going into our design tensions, we have what I think is the hardest tension to balance, which is standardization versus flexibility. And so the shared nature of a developer platform is an awesome opportunity to reduce the risk of drift, but we have to hold that in tension with the flexibility that developers often need, especially as our organization grows and the number of technical needs grows with it. So for example, right now my org is facing the consequences of building tens of services with an opinionated framework that has really not since aged well. And so now we not only have to revisit the approach to runtime support, but we also have to reconcile the tech debt that manifested from this decision years ago. And so reflecting on where we went wrong, but that we're doing now, is really just to engage with the users of those runtime platforms. And so I started off by saying this talk, the opposite of isolation is community. And so now we're approaching it more from the standpoint of driving standards with actual teams and learning communities of practice. Next, we have the tension of simplicity and complexity. And so as we respond to the evolving needs of our users, complexity is going to become harder to manage because the architecture that supports them is going to be likely to change, right? Whether that's to begin using event-driven communication or begin embracing client-side rendered front ends. And so this becomes another area that we need to be intentional about. And so, like tech debt, complexity is going to be inevitable, but we can compartmentalize it somewhat by making sure that developer-facing interfaces are simple. And so this leads us to the most common source of complexity in software engineering, which is integrations. And so we know the common design principle of reducing coupling between services, right? And the same applies to our work. Integrations are high risk because avoiding coupling is incredibly difficult. And that's why a lot of the selling points for vendors is their integrations, right? But integrations are also what lead to lock-in, so tread carefully. And so speaking of vendors, so remember our automation principle from earlier? So even though I just spent some time talking through design principles for building platforms, I want to emphasize again, give yourself permission to not design at all, right? The decision to build versus buy versus reuse should be our bread and butter. And deciding that we don't want to take on the work of building and maintaining a tool is a super valid one, because every line of code you write is a liability, right? Code isn't necessarily our bread and butter of platform engineering. Research, design, and technical decisions often are. And so, like I mentioned in the principles section, you do have to worry about vendor lock-in. And I'll emphasize this approach that we should be paying attention to how industries are defining open standards like open telemetry, SLOs, et cetera. And so holding these tensions in mind, let's talk about what I'm calling a platform recipe. And so this is a reusable framework with 4 pillars. And these allow us to enable, compartmentalize, or communicate the trade-offs of the tensions that we just talked about. And together, they make up the ultimate developer platform architecture. And so let's briefly review each of these pillars and then provide some examples. And so first, we have the parts of our architecture that provide standardization. And so 2 examples of how we might do that is through templates or opinionated frameworks, et cetera. And so secondly, we have the parts of our architecture that provide more flexibility. So for example, we might modify our framework to become more modular so that app developers can pick and choose based off their context. And we might also extend the way that we do templating by providing a CLI to make them more dynamic. Thirdly, we have the parts of our architecture that compartmentalize complexity through integration, since the first two pillars are the simple interfaces that I mentioned earlier. Right? These might be the APIs that tie the first two pillars together, or plugins to even front-end services that developers use to provide visibility that they even exist. And these tools are often not used directly by developers in their development, and are instead tools that we actually use to support developers in a more automated way. So for example, the tools that might pull our technologies together to support on-demand environments. Right? Engineers are going to use those environments, but the technical details of how we implement those should be abstracted away. And lastly, we have the parts of our architecture that communicate our design and decisions along the way, whether that's API docs or decision records for when we decide to build, buy, or reuse. And so I think a lot of people often think it's a little bit strange that have this can be considered part of our architecture, but as I've emphasized right throughout this talk, right, touch points between platform engineers and product engineers is essential. And this is a pretty good example of what that might look like. And so documentation is the first obvious one, right? I said that a lot of internal platforms can be replaced by documentation. And also we need to have support channels as complementary. And so we might also have a potential need to automate certain aspects of our support as we scale up the number of engineers that we're supporting. So for example, right, if your primary communication tool is Slack, integrations that consolidate questions and feedback centrally can enable us to have more feedback loops that can be really valuable for avoiding adoption issues. And so in the integrations pillar, I mentioned that plugins is an example to provide visibility of our tools that exist. And that's an essential answer to question to answer because visibility is needed to drive adoption. And so let's answer that question of how do we even provide visibility into our architecture? And so especially with the emergence of Backstage, an open source project which was created by Spotify, developer portals have become a way to provide centralized visibility into the developer platform ecosystem. And so the concept of a developer platform portal, I think, is a really compelling one, right? Ultimately tells the story of what it means to develop software at your company. And so by providing a unified view, not only does our platform become visible, it also facilitates visibility into any service using the portal. And so integrations are going to be a crucial part here, but because it's a centralized entry point, right, we do have to consider the risk of a singular point of failure. And this is why it embraces the idea of plugins, which are designed to be easily added or removed from the host application without total coupling. And so in other words, right, as we saw in our principles, right, it provides similar benefits that we see with microservices having concrete separation of concerns. So now that we've covered some of the fundamentals, let's move on to a more concrete example. And so given this is DevOps days, we'll focus on platform use cases related to infrastructure runtimes. And more specifically, I'll focus on the container runtime experience. And so reflecting back on the 4 pillars, we're going to embrace standardization here, the first part of the recipe, through base templates and images, which minimize repeatable configuration or code sometimes by centralizing it into a version template or image. And here, versioning is going to be crucial, especially for templates, because it's very easy to fall back into the trap of drift. And so now, when these first options aren't the right path forward for your organization's needs, but you still want to provide more flexible options, standard image artifacts are a great tool. And so here we still have a lot of decisions to make, including where on the spectrum of flexible we want to be, because these artifacts still have some avenue that we can inject standardization. And next, the integrations pillar, which represents either the integrations between components, so what this might look like is template generators for Docker files or Docker Compose files versus the integration between a container runtime platform and a Kubernetes platform. And lastly, all these different components and decisions can quickly get overwhelming, even when we're designing it with a lot of intent. And so not only do these decisions need to be reflected somewhere, we need to understand that infrastructure incidents are ours too. And the process of incident management should be one that fosters collaboration and knowledge sharing, which is a value that's reflected in our principles. And so what this looks like can be a little bit tricky depending on whether you have an SRE org and their specific operating model. But regardless, right, driving clarity over what it looks like is crucial to avoiding broken trust when our platforms inevitably fail. And so just to wrap this up, I've made some parallels between DevOps and platform engineering throughout this talk, and I hope it's obvious how important DevOps has been to this discipline, much in the way that it has been for SRE or other domains. And so our systems are complicated because people are complicated, right? And much like architecture design, this type of culture doesn't just happen, it requires intent. And the most compelling part of DevOps to me is ultimately the way that it transforms our culture to be one that fosters exactly that, intent. And so I started off this talk by saying platform engineering is a solution to building sustainable organizations. But perhaps the solution that we all really just need is actually just intent. Thank you.
Thank you so much. We've got a couple of questions. For the community perspective, can you give a practical method for building a well-balanced view on all ideas, opinions, and needs?
Yeah. So I have an extended version of this talk where I talk a little bit more about that specifically. And I talk about how learning is, and I reference Andrew Clay Schaefer, who he says learning is the most sustainable advantage. I modify that to be that communal learning is the most sustainable advantage, actually. So I think of it from that perspective, where what is the actual learning culture of your organization? Because if that's not there, all the rest of it is going to be probably really impossible, to be honest. So I think starting from there is, I think, one of the most crucial things that you can do. And some strategies I've seen is I mentioned communities of practice. And so those are usually swarmed around domains because people are going to be most excited about their domains. So yeah, I could go on, but I will keep it there.
All right. How do you manage features and roadmaps for platform engineering? Do you have product managers to define such, or is that organic in the community of engineers?
Yeah, this is a great question that I'm actively trying to solve at work, actually. So, I think we often inherit the idea of sprints from product engineering, and the more and more I am in platform engineering, the more I'm convinced it's just not a good model for us. I've done Kanban, and that was definitely better. But I think the thing that's often missing, especially when in the beginning stages of platform engineering, is you just kind of have to accept that you're going to be a little bit reactive in the beginning. You have to learn about your organization. You have to learn about the needs and the shape of it. And so yeah, I think in the beginning, I think I'm losing track of my question, but yes. So yeah, I think it's a balance of how much you want to be reactive versus proactive. If you're more on the proactive side, then maybe sprints are a more possible thing, but in my experience, most companies aren't there.
All right. Thank you so much, Lesley.
Cool.